guys. Hi, everyone. First of all, thank you so much for signing up and registering for our event. We had such an overwhelming response with this one, so we're really, really happy that you all are here. So, before we get started, a little bit more about our community. So, we are a budding community where we're uniting practitioners from design world and the data science and AI world all together to explore what this intersection has to offer. And as of today, we actually have a website, which I'm going to link you guys right now. So feel free to check us out. And every month, we release a new newsletter that explores one aspect of design with and AI. So feel free to subscribe and check us out on all our socials. And this is our third event. And this month, we are exploring data science and user research. And when we think of data science or machine learning or AI, we often think of it as something that has nothing to do with our day to day design works. Maybe some designers are even afraid that AI might take over our jobs as companies are building AI designer services. However, data science is not that far away from UX. And to be very honest, user experience and data science share the same goal to discover user behavior. It is just that data science works from a quantitative perspective, while user experience works from a relatively qualitative perspective. And today we actually have Grishma here. She is a data scientist with research ops team for user research and design at IBM Cloud and Data in San Francisco. She works across portfolios in conjunction with user research and design teams and uses data to understand user struggles and opportunities to enhance their experiences. So without any further ado, let's introduce her and welcome her. There we go.
Hi, thanks Avantika, and thanks to AIxDesign community for inviting me.
Really, really, really happy to have you here. So I can't wait to see what you have to share with us today.
All right, let's get started. Okay, can you see my screen fine?
Yeah, all good.
Okay, hold on a second. Oops, Zoom came in the wrong screen. So thank you so much, everyone. I'm really curious to know what your expectations out of the talk are. I think Avantika and I were very surprised when more than 400 people had signed up. So I really hope I deliver on all of your expectations. But otherwise, thank you so much for joining us. Good morning, good afternoon, good evening, depending on where you are in the world. It's a very strange time with COVID and all. So I hope you all are holding on there. And I hope you're doing okay. Please reach out to your friends. Please check in with your family. And of course, you do have this community that is there for your support as well. Okay, so you already know a little bit about me from what Avantika just told you. I work as a cross-portfolio data scientist, specifically for the research operations team, and that falls within our user research and design organization at IBM. Background is in machine learning and natural language processing, which is part of the reason why I'm giving this talk, and I really love public speaking, which is the other reason that I'm giving this talk. Okay, so just a quick disclaimer, I like keeping my sessions a little interactive. So I understand that you cannot unmute and just speak up, but feel free to use the chat whenever you have any questions. And I'm going to be asking a few questions to you as well. So feel free to type in your answers. We're all learning over here, so don't feel shy. Don't think any question is stupid or silly. Just feel free and comfortable over here. Okay, quick shout out. We recently launched this program has been there for a while, but IBM has our user research program for which any of you can sign up. And the good thing is that you will be working with us to create the future of our products. So you give in your opinion, your voice, and we take all of that feedback, give it to our user researchers, our product teams, and work on making the product better for you. And if you're interested, sometimes there's incentive where you can get maybe a $150 gift card or any other gifts, things like that, depending on the session you sign up for. If you're interested, please feel free to log on to this link, and I'll throw it in the chat at the end. and we'll share it in the Slack community as well. Okay, so I have a bit of trivia questions for you, just to get us warmed up. How much data do you think is produced every year? And I'm going to start monitoring the chat to see what you all think. Megabytes has to be more than megabytes. Gigabytes has to be more than gigabytes also, right? Because come on, like Netflix itself takes up gigabytes. Okay, I see someone, Jonathan, saying 100 petabytes. Okay. Anyone else? More than that, less than that? Many exabytes from Chris. Okay. Any other answers? Infinibytes. I like that one. Siddharth says a few zettabytes, quintillion bytes. We don't know, and that's perfectly fine because even, I'm sure the amount of data generated at the start of the stock and at the end of the stock is going to be very different. Depends on your definition of data, though. Fair enough. More than we can count, of course. Okay, so the correct answer is 16.3 zettabytes, and they actually had to come up with a new unit called zettabytes, which is 1 trillion gigabytes, just so they could be able to define the amount of data produced every year. That's a very, very huge amount, right? It's even difficult to even wrap your head around what that amount of data would look like. To give you a little more context, my next trivia question is, how much data do you think the average human brain holds? And I'm talking on a good day, not in an interview, not on a whiteboarding session, not in an exam where we all think it's zero, happens to the best of us. We're talking about, on a really good day. Do you think it's going to be more than zettabytes, less than zettabytes? How much less, how much more? Akshita says unlimited. Okay. Anyone else wants to guess? How much data does the brain hold? So the order of magnitude for the amount of data every year is zettabytes. Do you think it's more than that, less than that? Less than zettabytes, less than a zettabyte, less? I'll go with some petabytes on this one, less, few terabytes. Okay, I think all of you are kind of in the same range. The correct answer is yes, it is definitely in petabytes, 2.5 petabytes. So 1 zettabyte was 1 trillion gigabytes, and 1 petabyte is 1 million gigabytes. So it's by orders of magnitude smaller. Think of your favorite show. I don't know if it's Friends or Game of Thrones. Think of it playing, and this is, statistic back from when Netflix wasn't there. Think of a video recorder that would play continuously for 300 years. That's the amount of information in the human brain, right? Generations and generations of information. Okay, so before we get started onto going deep, I would like to clear out some buzzwords since it can be very glamorous to keep using some of these buzzwords, but oftentimes people might not be on the same page as us. So let's just go ahead and define what we're going to be talking about today. Very simply, data, any piece of information that can be stored, that can be processed, that can be manipulated, and you can derive some sort of insights from that. Data science specifically refers to any methods, processes, algorithms that help you extract insights from data. And user research is basically a study of target users where our researchers try to understand what are the user behaviors, needs, and motivations, right? So on the face of it, just looking at the definitions, it might seem like data science and user research are not that related. But hopefully at the end of the talk, you will all agree with me when I say that they are more related than meets the eye. And it's a dream really if the two work together. Okay, so how many of you are data scientists here on the call? And feel free to throw in the chat. And how many of you are user researchers? Okay, or even a mix of both, that's fine as well. But have you ever seen, okay, a user researcher, data scientist, aspiring data scientist, user researcher? Seems like we have a very good mix of the two. So let me go ahead and ask you, and this is something you can just think about. You don't have to answer it in the chat if you don't feel comfortable. If you're a user researcher, what do you think a data scientist does? And if you're a data scientist, what do you think user research is about? Right? So I just took these two examples, deriving a little from my own experiences, a little from what I've heard my friends in the industry talk about. So we have a data scientist on the left over here. And where did my cursor go? Yeah, okay. So she's like, hi, I'm a data scientist. And the guy on the right is, hey there, I'm a user researcher. And the data scientist thinks to herself, what do user researchers even do? I mean, we have designers, right? Is user research crucial to a product? I don't think so. I mean, I'm data scientist, we have engineers, we have designers. Why do we need user researchers? And on the other hand, our user researchers also doubting something. Data scientist, just a glorified numbers person. They only care about the business. They don't care about the users. Feel free to throw in the chat if this is something you've faced, this is something you agree with, disagree with. But I'm just kind of trying to generalize it a little bit over here. This is often what I've seen where people fail to understand, data scientists, engineers fail to understand the true value that user research brings. And user researchers might often feel that data scientists are just crunching away numbers without any objective insight. But hopefully we'll prove these two wrong. Okay, so my motivation for the talk, of course, data science and user research. So I'm going to start off with a few applications that help serve as motivations for why data science is helpful in user research. Of course, it helps you predict or even detect user struggles, and hopefully you can take some early action to prevent loss of customers. You can have some hypotheses that can be tested out with data science, really, really good at helping detect segments or user segmentation. You can analyze usage patterns. You can personalize, what kind of interface you want to show up. Of course, very helpful triangulation when you combine data with qualitative research, helps you evaluate features and predict user behavior, which I think is really important when you want to take early action and kind of nip it in the bud, right? If you foresee any problems with your product. Okay, so what I'm going to do now is in the next few slides, so we are going to be spending a bit of time looking at the stereotypical data science pipeline. So this is looking at it more from a data scientist perspective and what exactly are the day-to-day activities they do and how they go from a question or a data to finally an actionable insight. So we usually start off with a question or a data, go through the process of wrangling or kind of manipulating the data to fit the format that we need, cleaning because real world data is really messy, exploring to get a good idea of the data, creating models. Oftentimes we're not going to be getting it right on the first attempt. So you kind of see this loop over here. Finally, if you have a model you're happy with, you try to validate it, evaluate it, and at the end, you tell a story, which is the data storytelling part, to give some actionable insight. Don't worry about what each of these steps mean. We'll be breaking them down into smaller and simpler steps in the next few slides. Okay, so very first, you need a question that you want an answer to, right? Sometimes you can start off with the data and then dig into it to see what kind of questions it can answer. Oftentimes you start off with a question and then go and search the right data for it. Both are absolutely valid approaches. So let's start off with a question. Definitely try to formulate what question the stakeholder or you are trying to answer. Could be something like, who are the next 1,000 customers we are at the risk of losing and why? Can you predict click probabilities on the platform? Can we increase the revenue if we price our products a little differently? How likely is it that our user will buy a product, which is a lot of what Amazon, Netflix are doing at the back of their recommendation engines. They're trying to give you recommendations in the hope that you're going to click on it, either you're going to view it or you're going to purchase it. So these questions, as you can probably see, are very diverse in nature and they don't have to be restricted to just one field. Okay, so we have a question, then we go on to the data. You could either have the data or you could go ahead and search the relevant data. Both are absolutely fine. The data is usually categorized into three different types. The first is your structured data. So think of your, tabular format where you have rows and you have different columns. That's highly organized. So that's a structured data. Similarly, database, you know exactly what kind of structure or schema to expect. So that's a database again. The opposite end of the spectrum is unstructured data, where there is not any specific structure. So you can think of your documents, videos, audios. And then there's the third category, which kind of falls in the middle of these two, which is called semi-structured data. So I think the best example of this is an email, right? When you get an email, you kind of know that, yes, it will have a subject, it would have, time sent, it would have a receiver, a sender, and certain other properties. But within the email body itself, it could be text, it could be image, it could be a document, it could be audio, video, it could be pretty much anything. So that's why part of it is structured and the body of it is unstructured. That's why we call it semi-structured, because it falls in the middle of these two. Okay, now let's go on to the next step, which is called as data wrangling or data cleaning. So we asked a question, we got the data, and now we're going into the data wrangling step. And unfortunately, real world is extremely messy data. Oftentimes you can have incomplete data, you can have data that doesn't make sense at all. You can have data with really invalid values. So let's take an example of maybe you're sending out a survey for your product and you ask people to fill out some demographic information. Some people could say their state as CA, California, and some could actually write out California, right? So you don't want our algorithm to think that these two are separate things. So we need to go ahead and standardize it. So make it all just one value, either keep it as CA or keep it as California and apply that standardization across your entire data set. You might also have to do things like scaling or normalization, especially when you might have numerical values that are on different ranges, right? Like say, for instance, something could be 1 to 5, another thing could be 1 to 100. So make sure that the data is normalized. Like I said, real world data is often messy. You might have missing values, values that don't make sense, negative values when they should have been just positive. There are two approaches you can take in that case. If the percentage of data that's dirty or messy is relatively less and you have a pretty big data set, you can just go ahead and discard it. That's completely acceptable. The other, which I would say is slightly more common, is you can go ahead and try to interpolate the values. So for instance, you have maybe a time series data, right? Let's say the temperature every hour in a day. And you have the temperature for 1 p.m., you have the temperature for 3 p.m., but you miss the temperature for 2 p.m. In that case, it's completely valid for you to take the average of the temperatures at 1 p.m. and 3 p.m. and then put that average as the value for 2 p.m. You still want to kind of like mimic the distribution of the data without, kind of throwing the distribution in a bit of a jeopardy. You might oftentimes have some categorical variables as well. So you can go ahead and convert, let's say, yes is equal to 1, no is equal to 0. And of course, you need to make sure that you don't have any duplicates in the data because that might make our model learn that something is important where in fact it was just a duplicates coming up again and again. So we have the question, we got the data, did a bit of cleaning, we're happy with how the data looks like. And the next step that we go into is called as data expiration, which kind of is the initial investigation of data. So it's kind of getting your feet wet with the data and just understanding what are the different variables over here, what is the distribution of those variables, forming some sort of hypotheses at the end of these steps that you can prove or disprove in the next few steps. And you just want to cover any initial patterns or points of interest, something that you expected, that you want to dig deeper into, or something that's completely surprising and you want to investigate it further. After data expiration, we come into the model building part, which is kind of known as the whole, glamorous portion of machine learning. Before you start off model building, you go into a step that's called as feature engineering. And this is oftentimes where our domain experts or subject matter experts come into play. Let's say you're dealing with medical data, but you're not a medical practitioner yourself. You can take help of medical practitioners to tell you, these two values, they are interrelated, or these things are kind of redundant, just remove one. That kind of domain knowledge is really important if you're dealing with a data set you are not an expert in. Once you do that, you try to create some sort of important features from meaningful ones. Let's say one of your features in your data set is a timestamp. Now, the timestamp on its own is not going to give you much information, but you can use that to uncover slightly more important features. Like, let's say what season it was, what month of the year it was, what day of the week it was. And then those features will help inform your model and help predict or meet your objective, whatever you're trying to do. So that refers to as feature engineering, where you try to manipulate the features that you have into making slightly more important, slightly more relevant features. So once you're done with that, you go ahead and divide the data into what's called as training and test. And think of it as very similar to how humans learn, right? Let's say you're in a classroom, you're taking a course online. That is your training stage where you're understanding or grasping what the different concepts mean. And then finally, when you're giving an exam on it, or taking homework, that's kind of as the testing set, where you're trying to apply whatever you learned in your training stage. Similar to how humans work, how babies learn, that's what our machine learning models do as well. Then you go ahead and choose what exactly is the type of model you want. It could be supervised or unsupervised. I will explain in the next slide what that means. You tune some model parameters that are associated with the model itself and monitor against something that's called as overfitting, which I'll explain in the next slide as well. Actually, I can just explain it now. So overfitting refers to the problem of being super, super specific on the data. Now, there was this example where there were a bunch of researchers who were trying to create this sort of recognition algorithm using image recognition. And what they wanted to do was they wanted to see if something is a husky or if something is a werewolf. So you give an image of a husky or a werewolf and hope that the model predicts it correctly. They tried it on their test set. They got really amazing accuracy, greater than 90%, super happy, super pumped up, went ahead and submitted in all of those, top tier scientific journals. And then when they tried it on different test set, what they realized was they had actually not created a werewolf or husky detector, but they had done a snow detector. Now, why did this happen? Unfortunately, all of the images of huskies that they had used to train the model had snow as the background. So what the model did was basically came up with this correlation that said, if there is white in the background, which means it's snow, which means it's a husky. So that's overfitting the model, making it super, super specific to just the data that you gave the model, which is not what we want, right? So that's something we need to watch out for. And then finally, of course, you evaluate the model and see how well it performs. So let's take an example of an apple. Some of the features that an apple would have, the color, so that's red. What is it a type of? Is it a fruit or a vegetable? It's a fruit. What is the shape, so on and so forth. So those would form our features in our data set. Oftentimes people ask me, how do you go about and tuning the parameters of the model, or making sure everything works right? And I really like to quote this XKCD article comic, which says, two friends talking, hey, is this your machine learning system? And yeah, it's this huge big black box of calculus, linear algebra, all those really scary math terms, but you just put all of your data in and magically answers come out. And the friend again asks, okay, but what if the answers are wrong? And then the data scientist says, just start stirring the pile till they look right. And that's oftentimes what we as data scientists do, just kind of do a bit of trial and error. Okay, so I talked about supervised and unsupervised in the previous slides. So supervised learning is basically where your data set has certain labels associated with it. So let's say if you have a data set of emails, it's spam or not spam, right? If you have a data set of customers, did they buy something or they didn't buy something, they abandoned the cart. So those are the labels, and that's called a supervised because the labels help supervise the algorithm. The other category is unsupervised learning, where you don't really have any labels, but that's okay because you're just interested in knowing the structure of the data. So the best example of that is clustering, finding different similar segments or clusters. And then there's a third type that's called reinforcement, which is used mostly in your gamification AI or your robotics, where you're trying to train it, giving it an environment, giving it an objective, and based on whether it meets the objective or not, you give it either a reward or a penalty. So that's kind of reinforcing what are the right steps to make the objective. Okay, so now let's jump into the user research aspect of it, right? How data science can help. Hopefully you've gotten a good overview of the pipeline. We still have a few more steps remaining, but this is the majority of it, and we'll cover it in a bit. Airbnb is one of those companies that do a really fantastic job of integrating their data science and their user research teams. Let's go ahead through a few examples to see how they mended the two together. So Airbnb actually used data to determine host preferences. They had a bunch of different variables based on the location of the booking and the previous activity of the host, and they actually found out that there were different trends for how hosts in small cities would behave versus how hosts in big cities. For example, with big cities, they did not like having gaps between their bookings. And in small cities, they were like, it's okay if the booking or the rental goes empty for a month. We're completely okay with that. I'm not really sure why that happened. That's of course, where user researchers stepped in. But my interpretation would be that probably big cities are more expensive. You get more rent out of it, so they're not willing to go. Maybe with small cities, they are completely okay with doing that. I don't know. It really depends. So that's the job of a user researcher to find out. The next example, again from Airbnb, was they actually used a data scientist went ahead and discovered in the data that there were really high bounce rates from certain Asian countries. And what would happen is, and this is back in the days when Airbnb was, the new kid on the block, what they did was they had this neighborhood tab. So you could basically select a posting and then click on the neighborhood tab and then see whatever is around that, whatever your supermarkets or the nightlife or, monuments of interest. And once you went into that neighborhood tab, you kind of just keep clicking photos, and they basically forgot that they were doing a booking and they just went away. So what this data scientist discovered this and then went up to the user researchers and the engineering team. And what they finally decided on was, let us redesign it. So instead of having that neighborhood link for those certain Asian countries, what they did was they replaced it with the top selling destinations for that particular region. And that actually led to an increase of 10% in conversions, which I think is great, right? This is a perfect example of how data scientists, user researchers, the engineering team can work together. Again, another Airbnb example, something really intelligent that they did. And let me come back to the first two examples. So the first one was basically supervised learning or classification, because you're trying to predict if it's A or B. Is the host going to accept or reject? So you have these classes, right? And you have to predict one of those. The second one is also supervised, but it's regression, where you're trying to predict a number, right? What is the bounce rate for that particular region? So it's a number, that's why it's a regression and not a classification. But Airbnb didn't restrict itself to just these two traditional methods. They also used it for something really clever. And basically what they had to do was, once you go and search for a particular city for Airbnb, you have to understand what is the probability. You have to basically surface results that have a high probability of being booked, right? So instead of them going and trying to label the data with, okay, this is San Francisco, it's in the Mission District, it's super popular. This is in Austin, it's in the 6th District, it's in the midst of all the nightlife, it's super popular. Instead of doing that, they actually let their users drive the search. So based on the past users and how many bookings, whatever bookings they had done, they looked at the locations and looked at the other variables related to that. And then they came up with a model that would predict the probability of these bookings. And whatever had the high probability, which obviously was around either monuments or sightseeing places or nightlife, just came up on the search page. So they were just going ahead and increasing the probability of that booking being selected even more, which I think was very, very smart. Okay, let's go into our next step. So we did the data modeling part, but how exactly do you understand if your model is good enough? Which is where we come into the validation part of it. How do you understand how good a model is? How do you compare models if you have multiple models? Some of the very common metrics that data scientists used are called accuracy, which is basically the number of right or wrong, precision and recall, which depends on false positives, false negatives, and you can see the chart on the right that explains it a bit further. Another very interesting phenomenon, which I think a lot of user researchers might also be aware of, is something that's called as null hypothesis, which basically forms the foundation for type 1 or type 2 errors. So null hypothesis is nothing but you basically look at any two samples and you see if the difference that you observe between them, is it actually sampling error, is it due to chance, or is it a legit significant, statistically significant difference? So that's where the null hypothesis comes into play. Okay, so we got a good idea of how data science, the whole pipeline works, what data scientists do in their day-to-day lives. Let's take this example of ABN AMRO, which I believe is a bank. And what they wanted to do was they wanted to help their customer support representatives better and faster tag whenever a support ticket would come in. So they went to the data scientist team and they were like, can you do this for us? And data scientists were, yes, of course. This is nothing but, classification, or it's supervised learning because we have labels and you're just trying to predict what the label would be for a support ticket. And they came up with this really robust system that had a high level of accuracy, really good precision, all those metrics that we saw on the past slide. They were very happy with it. When they went to deploy it, what they realized was actually the time taken for customer support reps did not decrease, but it actually increased for them to file support tickets. Now, what had happened was that instead of just them having to manually label something, they were now presented with a really long list of 20, 30 different labels. And now they were instead spending time going through each of those labels to understand what was a good fit for that support ticket or not. This is to say that if you just blindly apply data science, you might on paper, on theory, have really good results. But when it's actually in production, it's actually in the real world out there, things might not be what you expect, right? Which is why user research is needed. So they did do better, faster tagging using machine learning, but unfortunately it did not lead to the results they want, which is why they should have had user researchers working with them and conducting some usability tests to understand if this system is actually decreasing the time taken or not. Okay. The last step of the data science pipeline is, of course, you have the insights, you have all of the model results. What do you want to tell? You go back to your stakeholders and try to answer the original questions, communicate those findings. Data storytelling, I think, is really up and coming. And I really like this because you focus on trying to humanize certain aspects of it, not just, thinking that numbers are just numbers, but the way that those numbers come or generate is actually through some user activity, or a human is doing something, right, to generate that data. It's a combination of narrative, visuals, and data. So narrative and visuals together help you engage. Narrative and data together helps you explain. Visuals and data helps you enlighten. And a combination of all of these three help you drive the change, which hopefully is what you are advocating for with the actionable insights that you have delivered from your model. There's a really good article over here that I've linked to, and Avantika and I will share the links in the Slack channel as well later. But highly, highly recommend to check this one out for a greater depth into data storytelling. Okay, so oftentimes I hear some of the user researchers saying great data science is more for quantitative stuff. But Google did something very interesting where they realized that conducting usability tests was actually time consuming and expensive. So what they did was they went ahead and trained a deep learning model, and they basically gave it a web page and certain properties of that web page. Things like what is the size of the web element, where is it located, what is the color of it. So, if it's a blue, it's a hyperlink. And then they tried to make the model predict how tappable each element was. And they actually had a lot of data. So deep learning generally requires a huge amount of data, but it's Google we're talking about. So they went ahead and they trained the deep learning model, and they found out that the model was able to predict if an element was tappable or not as good as the humans. So the model and the humans had a match of 90%, 90. So what they did actually was they went ahead and tried to simulate how users would conduct a usability test given the web page and the web elements in that. So I thought this was a very interesting application where people think of analyzing the data you have, but you don't really think of simulating the data, or doing synthetic data generation, which can help meet certain user research objectives. And Avantika, I think some of them are asking about the Slack channel. Yeah, I think you'll all send out the link for that later.
We'll give out the details in the end. Yeah.
Sounds good. Okay, I have another trivia for you. And hopefully the audio will play for this, but let me know if it doesn't. Actually, I'm just gonna. Were you able to hear that? Okay, any guesses what that song is? No audio, yes, no. Okay, a bunch of you heard it, a bunch of you didn't. Any guesses what the song is? Okay, well, it was, oh yeah, Shristi, and yeah, quite a few of you actually guessed it. It was indeed Sorry by Justin Bieber. Spotify has this kind of thing that they do at the end of every year. They find the outliers in the data, some with usually very embarrassing playlists, and they try to make billboard advertisements in that. So there was this person, dear person, who played Sorry 42 times on Valentine's Day. What did you do? Spotify, as someone rightly mentioned in the chat, actually does a great job of integrating their user research and data science teams together. And of course, I'm sure they have data scientists working to find out these outliers for these gems of user activity that finally gets advertised. But there's this very interesting case study where Spotify used a combination of the two for detecting an anomaly in user behavior. And I believe this was Spotify Australia, and they had just unveiled the Spotify premium feature of Spotify premium tier where you can skip any number of ads. And what they looked at was, I think they did a diary study where the users had to call themselves power users or medium users or just entry level users. And then what happened was, the data scientists saw that there were a few groups of users that would just skip 6 ads and not anymore. And this was a little weird, right? Because the user researchers thought that these were actually pro users. These were users who could skip an unlimited number of ads. They were a little curious why they would hit this limit of 6 ads per hour and then just, not skip ahead. So they went ahead, they actually spoke to these different users. So the data scientists picked out these outliers. The user researchers went ahead and interviewed and spoke to them about what exactly was happening. And turns out that one of the users had developed this mental model. So basically, Spotify allows you to skip 6 songs in an hour. And the user thought that it also applied to ads. So the user thought that he could only skip 6 ads an hour. That was the wrong mental model, right? And this discovery wouldn't have happened if it hadn't been for this combination of data science and user research working together. And then they came up with this, I don't know if you've seen, if you use Spotify, it comes with freedom to skip. So they kind of came up with that initiative based on this discovery, which I think was really great. Okay, so coming back to how exactly do user researchers and data scientists, where do they, come together? Where are they a little different? So you can see data scientists are slightly more on the quantitative side. They're doing a lot of modeling, A/B testing. Qualitative side is, of course, for the user researchers. They're trying to go ahead and speak to our users. So you can see they have slightly different route, but it's oftentimes the same destination of trying to understand what exactly the users are doing, right? So data scientists focus more on the user actions, and user researchers focus more on the user intents. You kind of have to have a combination of the two in a really good balance to understand what exactly the user is trying to do and what are their pain points, what do they finally need from the product you have. So it's a really it's a dream team. Data scientists and user researchers are better together. Like I mentioned in the previous slide, data scientists focus on quant, user researchers focus on qualitative, and both of them look at the world very differently, which I think is amazing because you kind of get new perspectives. You have, each side of the table bringing something new. And I really think that you need a good combination of blending people, which is the user researchers, and blending data scientists together to get a good picture, to get the full overview of what exactly is happening. The wonderful thing is you're not just restricted to one particular research method alone. You're not just restricted to data analysis, but you kind of get a holistic understanding when you combine multiple forms of data, and you kind of get rid of the cons of just that one single research method. It also helps you keep your biases in checks. For example, you might have user researchers going and talking to their users, and they might actually relate to a pain point very strongly, and that might create some sort of a bias. Or they might not relate to some pain point, and they might think, okay, this just happens with a minority. Of course, that can happen in the data as well. So a good combination of the two is really, really important. Finding correlations, the data can help you find correlations, which finally help the user researchers develop slightly more specific persona, slightly more specific hypotheses that can then be applied to just a subset or a group of users. And another interesting thing is sometimes data science can help you quickly iterate on projects, right? So I think this was, what was it? I think it was Airbnb who was trying to conduct this study. Their teams were trying to conduct this NPS study. For those of you unfamiliar with NPS, it is basically called Net Promoter Score. Oftentimes you fill out the surveys and you have this question saying, how likely are you to recommend this to a friend or a colleague? And it's a scale of 1 to 10. So that is used to come up with a metric that's called as NPS score. And what Airbnb wanted to do was see if that NPS score could predict if somebody was going to rebook or not. So they went to the data science team, they worked with them, and then they iterated on that, and they quickly realized that yes, it did help to predict if somebody would rebook, but very, very marginally. They kind of just decided to give up on that. They didn't think it was worth the investment. So think of data science as kind of an investment, right? Where you can quickly iterate, you can quickly put out a prototype and see if it's working or not without having to invest the entire product team into it and then finally finding out that it didn't work. And I think this, we are all more, driving more towards data-driven technologies, data-driven decisions. So it's really good when we have data that's, quantitative and qualitative, which is providing support. Okay, let's go on. So data is really the language, it's the voice of the customers. And this was very well said by Rochelle King. Data is the language your customers are using to talk back to you. You did something to their experience. Did that improve it or made it worse? You can measure that. That's them speaking back to you, whether it was working or not. Slightly changing directions, Avera Sampson at Microsoft said, all data is created by people, and all people create data. Today, we divorce people from their data, and that gives companies license to forget about the people behind the data. It allows us to divorce ourselves from the responsibility of what that data can do. Even as a data scientist, I'm completely being frank and open. Oftentimes, we can just be restricted to thinking in terms of numbers because that's just, kind of an occupational hazard. But I think, working together with user researchers, with designers, I've started to understand that, it is definitely a user. It's a person who's creating that data. And at the end of the day, these are just people. These are not just plot numbers on a plot. These are not just statistics, but these are actual breathing, living people with stories of their own, with things they're trying to do, just like you and me. Any talk about data or with anybody who deals with data would be amiss if I do not talk about the ethics of data. It's really important for all of us. You don't have to be a data scientist or a data analyst to be thinking about the ethical aspects of what you're designing, what you're creating. This is a really good checklist that I found by some of the pioneers in the field. List how the tech can be attacked or misused. For example, Google Home, Alexa, they are devices that have documented records of people using it to gaslight their partners. And I think till at least a few months, and I'm still not sure if this is the case, if they've improved this or not, but Alexa just picks up a phone call without sometimes asking you. And if it's like on a really low volume, so somebody could call you and they could basically eavesdrop and then use that information to gaslight you later, which is really scary. Definitely test that the training data is fair and representative. I don't know how many of you have seen those, automatic motion sensor soap dispensers, water dispensers. And this has happened to me as well. I go in the airports and it doesn't detect my skin just because I'm guessing the training data wasn't fair and representative because they did not train it on a variety of skin complexions. They just trained it on maybe, I don't know what the team was made up of. Very important to study and understand what are the different sources of bias. For instance, there was this one company that wanted to automate the human resource manager, and they wanted to automate the whole process of recruiting and selecting how you filter applications and call them for interviews. They thought machine learning is great for this. Why not? We have a lot of data. Let's go ahead and train it. And they went and did that. And do we have anybody called Jared on the call? Anyone? Say yes if you are. So what happened was that this machine learning model basically said that there were two predictors of if somebody would get hired or not. The number one was if their name was Jared, which probably says that maybe that company had a lot of Jareds. It's also a very white American name. So, that could be a source of bias over there. The second predictor was that if they had women or women anywhere in the resume, they would not get hired. So it could be playing for a women's lacrosse team. It could be a part of the women's debate club. You would not get hired. So these were biases in the data. And when you kind of use that data to train your models, the biases are of course going to reflect. And I'm sure all of you are familiar with the racial injustice and the civil movements that have been happening, right? A lot of these are also because of the fact that we have these biased systems in place and nothing has really been done to mitigate that. That's why it's really important to have a diverse teams with diverse opinions, diverse backgrounds, diverse thoughts, not just from different racial backgrounds, but also diversity in thoughts, your perspectives and opinions. Really important to have clear, explicit user consent and data protection. And I think the GDPR regulations is a good direction in that sense. Make sure that it's fair over time, not just the first day. I don't know how many of you heard of Microsoft had this chatbot called Tay. I think it was a few years back, and it basically learned from whatever people would tweet at it. Within 24 hours, it became so racist and so nasty, they had to take it down because people were tweeting it with racial slurs and all sort of abuses, and it kind of just learned from that. So yeah, be sure that it stays fair over time. And of course, if something bad happens, make sure you have a strategy to redress it and to shut it down. So hopefully this was a really good overview of how data scientists work and how, when they join forces with user researchers, it actually is what I like to call user science. So you kind of understand the user and you basically take the user action part of it, you take the user intent part of it and try to combine the two. And then hopefully we can understand what exactly it is that the users want and work to create better products that they would love. These are a few resources, and I'll be sharing this in the Slack community as well. But feel free to reach out to me. That's kind of my contact information. And I guess we can take up some questions now.
So if you guys have any questions, feel free to put them on the chat right now. Well, if there are no more questions,
So yes, I think Sarah asked, are there any examples of data science support and discovery research? Yes. In fact, that's actually one of the projects that I've been working on at IBM. We are in the midst of creating a research repository. One of the interesting things is that when you have access to data, you can investigate it and see if there are any outliers or any things that make sense. So what we are trying to do is have all of this data from customer feedbacks and research work being done and help us understand what are some areas that need deeper investigation. Maybe there are a lot of support tickets being filed on that one particular thing. Maybe the product teams think it's a minority or it's an outlier, but that's actually not the case. So I think once you have that huge amount of data, of course, it depends on what data you have, you can try to investigate and look for certain patterns or trends, and that can help inform your research strategies for what user researchers should look deeper into. Okay, there are a bunch of questions coming in. You talked about how data science can help with user research. How can you, as a user researcher, use data science? It really depends on the amount of data you have and the kind of data you have. I have been working with some of my peer user researchers to synthesize data. So a lot of times you might have these bunch of text scripts and transcriptions. You can actually use data science to quickly understand what are the key themes or the key summaries, and then the user researcher can dig deeper into it. So I think any sort of analysis, definitely your statistical testings as well, that's really important. In your experience, this is from Luke, are UX and DS departments compartmentalized, or have you seen any researchers that are hired specifically because of a data science background? Generally, I've seen most companies tend to keep user research and data science separate, but like I mentioned, Airbnb, Spotify, they're all doing a really good job of it. IBM is also with my organization, with the organization that I'm in. I think for user researchers, at least what I've seen in the job market, there's a slight movement towards uh, I wouldn't say it's absolute necessary to have a data science background or a quant background, but I've definitely seen those people having a bit of an added edge. So it's kind of a bonus. I've also seen a lot of times user researchers come into the company, they collaborate with data science engineers. a lot of your quant researchers and basically upskill themselves as far as statistics is concerned. Rajasi asks, I'm a user researcher. I want to learn more about data science and UX. Could you recommend any online sources? Yes, this list that you see, which we'll send out shortly, should be a good starting point. All right. Jonathan asked any recommendations for tools for analyzing qualitative interviews. At IBM, we use a tool that's called as Auto.ai that helps you get those transcripts and analyze it further. What I've been doing so far, and this is of course because I work with them, is I basically created the script that you can just plug in data and you immediately know what are the top words that people have used, what are the top phrases, what are the top themes, what's the top sentiment that's coming across, what are the different concepts that keep occurring. So I think that's good, but I'm sure there are a lot of other tools out there as well, and your peers can probably put in the chat their recommendations. When doing user science, is there a good data science to user researchers ratio? That's a really good question. I have not thought about it. I can tell you about the ratio at my organization. I'm one data scientist for a team of 75, 80 different user researchers. So that's probably not the ratio you want. We are looking to get more, of course. But I think it really depends on the complexity of the problem that you're trying to solve and the amount of data you have. Oftentimes what can happen, and this is what I discovered in the early part of my job, is that sometimes organizations are not data mature. So what data scientists might end up doing is creating an infrastructure to amalgamate all of those sources of data, clean that data, and then go on to the data analysis part. And this is still the middle step. The data modeling, prediction, all of that comes even much later. So I think it really depends on how mature your organization is. And of course, the more mature you keep getting in, you definitely need more data scientists throughout that journey. Lorenzo asks, how can we choose the things that should be investigated during discovery with user research and the things that should be discovered via quant? Data with the live solution and A/B testing. Yeah, I think that's one way to go. Again, and this is kind of a caveat that comes with being in data science. I'm going to answer most of those questions as it depends, because unfortunately, it really does depend on the problem you're trying to solve, the amount of data that you have. But I think if you have a good amount of data, you can probably do something like anomaly detection or outlier detection to understand what are things that seem a little out of the obvious. Maybe you're seeing really high trends somewhere. So that could be something that can be investigated further with user research. And like I mentioned, that Spotify skippable ads example, I think that was such a great example of that. Triangulation with qualitative research means, I believe our user researchers on the call will probably be able to answer this a little better than I do, but it basically refers to how you combine quantitative and qualitative research together to try to find some insights. Did you learn something unexpected from training a deep learning model to reproduce usability testing? From Teresa. So Teresa, that was actually a case study from Google AI. I have linked to that article with slightly more details over there. So you can take a look at that. As much as I would love to do, I don't think we are yet at that stage for deep learning, but hopefully we're getting there. V asks, any advice on what to learn first if you are a mid-career marketing professional wanting to transition to data science? I have a list of beginner data science resources. So what I'll do is I'll append that to the slides and then we can share that out. Nicholas or Luke, oh, that was, I guess, okay, let's see if we have any. Varsha says, you mentioned objectivity, diversity, fairness in the training data. However, this isn't always the best way to reach your users if they are themselves not diverse. How can marketer user research be used to ensure that user groups are reflected in the training data? I think this is, again, kind of where the combination of the two comes in. I've been on projects where we have, kind of quantitative data from a bunch of different users, and then the qualitative data is from slightly different users. So maybe looking at two different user groups to understand if there are any overlaps, any similarities over there. But I absolutely agree. This is something that all of us individuals over here and all of the companies also need to do a better job of. As far as the diversity and fairness in training data is concerned, there are a bunch of different frameworks out there coming up as well. I think IBM has something that's Auto AI and another fairness kit, AI fairness kit. Google has a what if tool. So those are really good tools that you can check out as well. Valeria asks, what is the difference between data scientists and conversion rate optimization specialists? So Valeria, I would believe that data scientists is more of a general term. They could, of course, be working as a part of their project on conversion rate optimization. But yeah, I'm going to guess that's it. I actually haven't heard of this term. So thanks for informing me of that. Is there any suggestion to learn data science for user researchers? Yes, and I think some of these resources over there would help you. But starting off with the basics, and I really recommend starting off with a programming language. Python is usually easy to get into, and just getting your hands dirty with the data. I think that's really the best real world experience can you have. Nadia, how do you watch out for optimizing for vanity metrics at the cost of users' well-being? How can you be mindful of this on a day-to-day basis and throughout your pipeline? That's a great question, and I think it's a very important question. So one of the ways, if you look at it from a data perspective, is you kind of look at an aggregate of data. So you kind of increase the amount in the hope that it kind of normalizes all of that. But watching out for optimizing vanity metrics at the cost of users' well-being, I think that's where the whole ethics part and user research and trying to look at it from a more human perspective comes in. And if any of you have better answers, please feel free to pitch in the chat. Aparna asks, does analyzing qualitative data mean we ask qualitative nature sort of question, but still get output and numbers, right? Yeah, it depends on the type of question you answer. Generally, the qualitative data I've dealt with are more open-ended responses that are, kind of like your text responses for surveys. Okay, two last questions on explainable AI. Yeah. Yes, it is such an important field, and IBM actually has been doing a lot of work in that. I can point you to that. I think it's really important because AI is touching every aspect of our lives. Either we know it or we don't know it, and data scientists really need to do a better job of not, being focused on getting that really high accuracy, but more focused on, is it explainable? Can you explain all of the decisions, why that AI gave a certain output? We're moving in that direction. Of course, it's not at the pace we want, but it's an important field, and I hope some of you might go on and explain and that explore it further. Okay, I think we are at time.
Yeah, I think that's all the questions we had. So thank you so much, Grishma. We learned so much, and I know say this on behalf of everyone as well. But if there's anything else you guys want to know, feel free to reach out to us on our socials. And Grishma shared her details as well. So we'll put that on our Medium article that we will release next week. And so to get access to all of that, you can follow us on our socials. I'm dropping our website link here. So, yeah.